make sure you get your date, your page number, your learning target, and your title, and you get all this stuff in your table of contents. Today we're going to talk about a second way to solve a system of equations, and this is by the substitution method. Okay, so the reason we have multiple ways is because not every set of equations is going to be easy to solve by the graph method. For example, if you have an equation that crosses at not a whole number order pair, for example, if one of my answers to my system of equations, let's say that they crossed at 3.57, you're not going to be able to see that that's 3.5 and not 3.6 on a graph. Another thing is maybe you don't always have a graph handy, so a substitution method is a method that would work. Alright, so substitution method, what you want to think of it as is a substitute teacher. A substitute teacher takes your place for the day. So what I want you to look at is notice that here, this thing tells me that y equals 3x. That means y and 3x are the same thing. So that means instead of a y, I can put a 3x. It can take its place without changing the equation. So x plus y equals negative 32. All I'm doing is rewriting this second equation right here. And I have x plus y. Well, instead of y this time, we're going to put a 3x because this tells me that they're the same thing. Now I know how to solve that equation because I don't have any y's in it. All I have to do is solve it like normal at this point. So when I go to solve this equation, first thing you're going to look and see, can I distribute? No. Next step, can I combine like terms? And I can. 1x plus 3x is 4x. And then I'm going to bring down my negative 32. Next step, trying to get x by itself, divide both sides by 4. And x is equal to negative 8. Remember, I'm looking for an ordered pair. That's what we did with the graph method. You're trying to find the ordered pair where they cross. So the x value of my ordered pair is negative 8. Now I need to find the y value. And you have options here. You can choose either one of the two original equations and plug it in and solve for y. This one looks easiest to me, so I'm going to plug it in. Y equals 3 times x is negative 8. Y equals 3 times negative 8, which is negative 24. So my answer, where they cross, is the ordered pair negative 8, negative 24. So again, think about the graph method. You would have to have a coordinate plane that went all the way down to where your y values were at least negative 24 so you could see where these things crossed. So that wouldn't be very practical, and this took a lot less time than drawing that kind of graph. So that's why we have multiple methods. So let's try it again. In this one, it tells me that y is equal to 2x minus 3. Alright, so since that's what y is equal to, that means I can substitute these in there for each other. So since this is equal to y, I can put it in the first equation instead of a y. It's substituting in, it's taking its place, just like a substitute teacher takes your teacher's place for the day. So I have 4x plus 3 times, remember, y, I'm going to substitute something in, so I'm going to leave it blank, equals 31. All I did was rewrite this equation, 4x plus 3 times y equals 31. Well, instead of a y, we said we were going to substitute in 2x minus 3. And now I can just solve my equation. So first step in solving equations is, can I distribute? And I can. I'm going to distribute 3 times 2x and get 6x. And it was positive. 3 times negative 3 and get negative 9. And then bring down all the things I didn't use. I haven't touched 4x and I haven't touched 31. Next step is, can I combine like terms? And I can. That gives me 10x, bring down the minus 9. Next step are all my variables on both sides, and they are. So I'm going to box my variable. How do you get rid of minus 9? Add it. Add it. And I get 10x equals 40. Divide both sides by 10. And the x value of my ordered pair is 4. This is where they would cross on a graph. So now I need to find my y value. And I can find my y value one of two ways. I can plug it into either equation. Well, I think this second one looks easier. Y equals 2 times x minus 3. Well, for x we got 4. So I'm going to put a 4 in its spot. 2 times 4 is 8. So y is equal to 8 minus 3. Therefore, y is equal to 5. So the ordered pair where they cross is the ordered pair 4, 5. One more example. This will be example 3. We've got 2x plus y equals 6, and then x equals 3y plus 3. So let's look at what we're going to substitute in there. See how this equation is equal to x, this expression. So instead of an x, I'm going to put it in the top equation in x's spot. So let's rewrite that top equation. 2 times x, I'm going to replace it to leave a space, plus y equals 6. Well, instead of an x, I'm going to put a 3y plus 3 because we said those two things are equal to each other. Now I'm going to distribute. 2 times 3y is 6y. 2 times 3 is 6. Bring down my plus y, I didn't touch. Combine like terms. Subtract 6 from both sides. 7y equals 0. Divide both sides by 7. 0 divided by 7 is 0. So the y value of my ordered pair, I got 0. Now, I'm going to plug that y value in, and you can plug it into either equation and see that you'll get the same answer. I think the second one looks easier, so I'm doing x equals 3 times y plus 3. Well, y was 0. So x is equal to 3 times 0, which is 0. 0 plus 3, which is 3. So it's the ordered pair 3, 0. That's my solution. That's where they cross.